So this video is going to cover one of our forms of a quadratic. So we have standard form, vertex form, and factored form. This video is going to focus solely on vertex form. I do want to let you know that if you're watching this, I'm going to start from the very beginning with the very basics, just so that you can get a good comprehension of what's going on here. So if you don't need to know all this beginning stuff, fast forward and move through the video wherever you feel like you need it, and then you can apply it to what you are practicing, okay? So the first thing that I want to mention, even before we look at vertex form, is I want to look back at my original parent function of a quadratic, y equals x squared. We're going to graph that and look at what that looks like, because that's going to help us to understand where this even comes from and why we graph it the way we do. So I'm going to zoom in on my parent function, okay? So we're going to use a table, and we're going to kind of plug in and plot points so that we can see what exactly this function looks like. A quadratic is going to be the shape of a parabola or a U-shape, right? So we should end up with something like this or like this, depending what we are given, okay? So what I'm going to start by doing is I'm going to plug in values of x to get me values of y so that I can plot those. So for values of x, I'm going to use just smaller numbers. I'm going to start at 0 so that we see what that looks like. And then I'm going to plug in a 1 and a 2. So when I do that, 0 gets plugged in for x. So 0 squared just means 0 times 0, which just gets me 0. If I plug in 1 for x, well, 1 squared just means 1 times 1, so that's 1. And then if I plug in 2 for x, well, 2 squared just means 2 times 2, or 4. So let's graph these right now. So I have a point 0, 0. I have a point at 1, 1. And I have a point at 2, 4. Okay. Something that we know about a parabola is that it is symmetrical, meaning if I were to split it in half or cut it down the middle, it should look identical on both sides. So with that, I'm going to plug in a -1 and a -2 so that we can see what happens on the other side of my parabola. So if I plug in a -1 for x, well, -1 squared means -1 times -1, which is still +1. And then if I plug in -2 squared, -2 times -2 gets me a +4. So now I'm going to plot the point -1, 1, which is going to be here. And then I have -2, 4, which is going to be here. I'm going to connect those points. Let's try that again. Oops. Here and here. So as you can see, this is kind of where my line of symmetry would be, right? It looks the same on both sides. Okay, so we're going to use this concept to help us develop how we're graphing in vertex form. So let's go ahead and zoom out and come back over here. So I need you to notice that my original function says x squared. In my vertex form, I still have x being squared, but we have 3 other letters happening. I have an A, an H, and a K. All those letters are doing is causing my graph to shift or change form or transform in some type of way. So let me remind you what each letter does. And we did this by using Desmos to kind of experiment with, hey, what happens when I plug in this number here? How does it move and how does it change? Okay. So one thing that the A value does is, remember when there's a negative in front, it's going to reflect my graph or just cause it to go upside down. Okay. If my A value is greater than 1, it's going to stretch and kind of get really skinny. So something like that. If my A value is between 0 and 1, or it's a decimal or a fraction, it is going to do what we call compress. So it's going to get wider. It's going to look more like this. So those are all the things your A value can do. Your H value here is going to do something a little different. Your H value is going to cause a horizontal change in your graph. So this H value is going to move your graph left or right. So we're going to call that a horizontal shift. And what happens here when I move left or right, we actually do the opposite of what we see. And let me explain why. So in my original equation, I have x minus some value, right? Let's say for this h, let's say I plug in a positive 5 or just a regular 5. My equation would read x minus 5 because that's exactly what I plugged in. But because I technically plugged in a positive 5, I should be shifting to the right because it's positive. But in my equation, it would say x minus 5. So that's why whenever you see that minus sign, you're actually going to be shifting to the right because we really plugged in a positive value here. And then oppositely, if we saw something that says x plus a value, well, to change this minus to a plus, let's say I plugged in a negative 5 here. So I would have x minus negative 5. What happens with two negatives, a negative times a negative becomes a positive. So if your equation says x plus 5, you had technically plugged in a negative 5. So that's why when you see a plus, you actually move to the left. So we only change the signs for our horizontal shift, okay? And then on the outside over here, my k value is going to cause a vertical shift. So it's going to move it up or down. And with this shift, you just do exactly what you see. So if you see plus 5, you move up 5. If you see minus 5, you are moving down 5. Okay, so let's go ahead and try this out. So my first example says y equals negative 2 times x minus 6 squared minus 1. Let me remind you, this negative 2 is your a value. We have x minus 6, so that 6 is my h value inside. And then I have minus 1, which is that k value out here. Okay, so our original function, if you notice, started at 0, 0, right? Started at the origin. Okay, so here my graph is going to shift. It says x minus 6, but remember we said technically you had plugged in a positive 6, so we're actually moving to the right by 6. And then my vertical shift tells me that I'm moving down by 1. So your first point is going to be at positive 6, right? We move to the right 6 and down 1. So this is where your vertex is going to start. So I'm going to put a point right here. So again, my vertex is at positive 6, comma, negative 1. Okay. Well, my axis of symmetry has to go through that vertex because that's kind of like my center point. Right? Kind of like if I came over here to my parent function, wherever that vertex is at, that's kind of where my graph gets cut down the middle. So essentially that line of symmetry or that axis of symmetry is going to be through whatever your x value is of your vertex. So that's going through 6. Okay? And then we'll fill out the rest as we go. So here's the important part. Where do I get the rest of my points at? I know my vertex moves to the right 6 and down 1, but how do I know what the rest of my graph is going to look like? Okay, let's go back to this parent function. Originally, my function here shows me that from my vertex, I end up moving over 1 and up 1, right? Because when I plugged in a 1, I got a 1 out. And then again, from my vertex, I move over 2 and up 4, because when I plugged in a 2, I got a 4 out of it. This pattern right here, guys, is what you are going to use every single time when you are graphing and you need to apply your a value. Notice here, your a value goes in the very front. Your a value here is just a 1. So I'm not changing anything about my original graph. 1 times something just gets me that something. So there's no changes here. So let's come back over here. So our pattern here was that originally on a table, I go to the right 1 and then I move up that 1 space, right? And then I go to the right 2 and I move up 4. from that space, okay? But what happens here is when your a value is not 1, so the a value is that number in front, when it's not 1, you end up multiplying that movement that you're making, this going up by 1, going up by 4, you have to multiply by this a value. So I'm going to multiply by -2. So now, well, if I see a negative, I know my graph is going to flip upside down, and then that 2 does something different. It's going to make it kind of stretch and get skinnier by a factor of 2. So let's go ahead and multiply this out. 1 times -2 is -2. And then 4 times -2 is -8. Okay? So essentially, my graph is going to transform by a factor of -2. So let's draw our other points. I'm going to go over 1, but instead of over 1 up 1 like our original graph, I go over 1 down 2. So my point goes here, okay? And then again, instead of going over 2, 1, 2, and down 1, 2, 3, 4, that's my original graph, it stretches by a factor of -2, so I actually go down 8. So my other point is going to go over 2, down 8. It's going to come off the graph a bit, over at -9. So I went over 2 and down 1, 2, 3, 4, 5, 6, 7, 8. Now, that axis of symmetry tells me that whatever my graph looks like on one side has to look like that on the other side. So you can just reflect those points over here. And there we go. That's my graph. Let's go ahead and fill out the rest of this information. My graph, as we see, is going to open down, which we should have known because of that negative in front. I have a maximum point here because I have a highest point. Since it's flipped upside down, the highest point of my graph is at the top. If it was facing up, for example, like this, I would have a minimum point. See how that's the lowest point of my graph? But that's not what we have here, okay? From this graph, your y-intercept is the point of your graph that crosses or touches the y-axis. There is a way to find this, but that is not my focus for this video. So I'm just going to say it's unknown from my graph. That is a focus that I will have in a different video. We know it's going to eventually, see how it keeps going down? It's going to go down. It's going to go further down. Eventually, it'll touch the y-axis. But for now, we just say it's just unknown. You still have one, though. And then my x-intercepts here, well, that's where my graph touches my x-axis, but if you notice, it's going to keep going down forever. So it's never going to touch my x-axis. So here, I actually do have none. So there's nothing for me to write there. Okay? Let's go ahead and do one more example. I have 1/3 x squared plus 5. Okay, so let's look back at our original form. I have an a value in front of where that x squared technically is, right? Very front. Whatever's in parentheses causes a horizontal shift. Whatever comes after that squared term is my vertical shift. So let's come back here. So technically, do you see how there's no parentheses? I didn't subtract an h or add an h. It's just x squared, kind of like my original parent function. So that just means I'm not moving left or right. There's no horizontal movement. That's all it means. But you see how I have that number at the end that comes after the squared? That is my vertical movement. So I'm technically going to start at the origin, but I'm going to go up by 5. Okay? So we start at 0, 0, but I go up by 5. So my vertex is actually going to be there. And then again, since my vertex is there, I know this is kind of where my parabola is going to cut down the middle. So my vertex is going to be at 0, 5, because there was no horizontal left or right movement. Your axis of symmetry is going to be at x equals 0. It cuts through 0 on the x-axis. Okay. My A value here is 1/3. That is going to play a role in what my graph is going to look like. Okay, so again, we're going to use that little table that we made. Remember my parent function goes over 1 up 1 and then over 2 up 4? Well, we're going to use this table that we did, right? It goes over 1 up 1, over 2 up 4. That's my parent function. But because my A value here is something different, up here it was a -2, down here it's 1/3. So we're going to make that table again. But instead of going up by 1 and then up by 4, I need to multiply by 1/3. So when I do that, 1 times 1/3 is just 1/3 or 0.33. So I'm just going to put 0.3. And then 4 times 1/3 or 4 divided by 3 is 1.33. So I'm just going to put 1.3. Okay. It's okay to get values like that. That's totally fine. So from my vertex, I'm going to go over 1, but now I'm going to go up 0.3. So I'm going to go over 1 and up 0.3. Maybe about here, just below kind of where the halfway point is. And then from the vertex again, I'm going to go over 2, but instead of going up 4, I'm going up 1.3. So I'm going to end up about here. And because my line of symmetry or axis of symmetry cuts it in half, I know that my points will be in the same spot right on the other side. And we go like this. So do you see how I had a fraction in the front? See how it kind of opened it up and made it a bit wider? So that's what we talked about at the beginning. It's going to kind of compress it, kind of like it got squished down from the top and opened up on the sides, okay? So this is going to open up, which we could have said because it's a positive A value. Here, I have a minimum because notice I have a lowest point right here, right? That's the bottom of my graph. Your y-intercept here is actually the same as your vertex because that's where it's touching the y-axis, so at 0, 5. And then for your last one, for your x-intercepts, again, it's facing up now, but it's never going to touch my my x-axis because it's going to go up forever. So it's never going to go down and touch that x-axis. So again, I actually have no x-intercepts here. Okay, so hopefully this helped. And good luck solving the rest of your vertex form problems, or graphing, I should say.